The universe is vast. Our galaxy, the Milky Way, contains hundreds of billions of stars. Each star is a sun, potentially with its own family of planets. And there are hundreds of billions, perhaps even trillions of galaxies in the observable universe. That's an astronomical number of potential homes for life. The sheer scale suggests life should be common. Yet, when we point our telescopes to the heavens, what do we find? We observe breathtaking nebulae, distant galaxies, and the faint glow of ancient light. We detect planets orbiting other stars, some even in the habitable zone where liquid water might exist. But from intelligent life, we hear an eerie, profound silence. This silence is one of the greatest mysteries confronting science today. Why in such an enormous cosmos does it seem like we are alone? This question echoes in the halls of observatories and laboratories worldwide. It fuels our curiosity and drives our exploration. For decades we have been listening, hoping to catch a whisper from a distant civilization. We have scanned the radio waves, the light spectra, and peered at distant worlds. The numbers predict a bustling cosmic city, but we seem to be in a quiet, perhaps isolated cosmic village. The mystery deepens when we consider the age of the universe, roughly 13.8 billion years. Our own civilization is a mere infant on this cosmic timescale. If other civilizations arose, some could be millions or even billions of years older than us. But the evidence remains elusive. This profound puzzle has a name, the Fermi Paradox. It is named after the brilliant physicist Enrico Fermi. Sometime around 1950, Fermi famously asked, "Where is everybody? Given the high probability of extraterrestrial life, why have we found no evidence of it?" The universe is old enough and vast enough that, statistically, someone should have shown up by now. The paradox arises from the conflict between the high estimates of the probability of extraterrestrial civilizations existing and the lack of observational evidence. Scientists find the Fermi paradox troubling because it challenges fundamental assumptions. It makes us question our understanding of how life arises. It forces us to reconsider the likelihood of intelligence evolving. The question, "Where is everybody?" still hangs in the cosmic air unanswered. One compelling explanation for the Fermi paradox is the concept of the Great Filter. This theory suggests that there is some incredibly difficult step in the long chain of events leading from non-living matter to a spacefaring civilization. This step is so improbable that it acts as a filter, preventing almost all potential life from reaching an advanced stage. The crucial question then becomes, where is this great filter in the timeline of life? Is it behind us, meaning we are incredibly lucky to have passed it? Or is it still ahead of us, posing a dire warning for humanity's future? If the great filter is behind us, it could be the initial spark of life itself, abiogenesis. Perhaps the transition from non-living chemicals to the first self-replicating organisms is an extraordinarily rare event. If we are among the very few to have successfully navigated this filter, it would explain the silence. Alternatively, the great filter could lie in our future. It could mean that many civilizations arise, develop technology, and then inevitably encounter a challenge that leads to their demise. This could be self-destruction through nuclear war, catastrophic environmental damage, or some other unforeseen peril. If this is the case, the silence of the cosmos serves as a chilling warning. Another perspective is the rare Earth hypothesis. This idea suggests that while simple microbial life might be relatively common, the conditions needed for complex life like ours are exceptionally rare. What if aliens are out there, but their technology is so advanced, so different, that we simply cannot recognize it or detect it? Consider our own technological trajectory. A mere century ago, radio was cutting edge. Today we are exploring quantum communication and artificial intelligence. Imagine a civilization a million years or even a billion years ahead of us. Their methods of communication, energy generation and travel might be based on physical principles we have yet to discover. They might not be using radio waves that SETI projects are designed to detect. Perhaps they communicate via neutrinos, gravitational waves, or some exotic particles we don't even have names for yet. It's also possible that advanced civilizations transcend biology as we know it. They might become post-biological, perhaps uploading their consciousness into vast computational networks or existing as pure energy. Such beings might have entirely different motivations and modes of existence. Their technology might be deliberately unobtrusive or designed to be undetectable to emerging civilizations like ours. Perhaps there's a prime directive of sorts, a galactic policy of non-interference with less developed worlds. the universe could be full of their works hidden in plain sight. Despite the silence, humanity has not given up the search. The James Webb Space Telescope, launched in late 2021, is a prime example. Its powerful infrared capabilities allow it to study the atmospheres of exoplanets. By analyzing the light that passes through an exoplanet's atmosphere, JWST can look for biosignatures, chemical fingerprints like oxygen, methane, or water vapor that could indicate the presence of life. Finding such signatures wouldn't be definitive proof of aliens, but it would be a monumental discovery. The traditional search for extraterrestrial intelligence, or SETI, also continues with renewed vigor. For decades, SETI projects have used large radio telescopes to listen for artificial signals from distant star systems. Modern SETI projects can scan billions of radio channels simultaneously and cover much larger areas of the sky. Organizations like the SETI Institute and initiatives at various universities keep their electronic ears open to the cosmos. The Breakthrough Listen initiative, funded by Yuri Milner, is the most comprehensive SETI search to date. Alongside listening, there's Breakthrough Starshot, aiming to send tiny light-propelled nanocraft to Alpha Centauri. These ongoing efforts highlight our relentless curiosity and our technological ingenuity. The search for extraterrestrial life is a marathon, not a sprint. The quest is evolving, driven by the profound possibility that we are not alone. The search for extraterrestrial life is more than just a scientific endeavor. It's a deeply philosophical one. The discovery of life beyond Earth would fundamentally alter our understanding of our place in the universe. It would answer one of humanity's oldest questions. Are we alone? If we find life, it would suggest that biology is a common cosmic phenomenon. This would have profound implications for religion, philosophy, and our entire worldview. Conversely, if decades or even centuries of searching continue to yield nothing, that too would be a discovery of immense significance. It might suggest that the conditions for life, or at least intelligent life, are incredibly rare. This could instill a greater sense of responsibility for protecting our planet and our species. Scientifically, the search for extraterrestrial life pushes the boundaries of many fields. Astrobiology draws on astronomy, biology, chemistry, geology, and planetary science. Studying extreme environments on Earth helps us understand the potential for life on other worlds. The quest compels us to develop new technologies benefiting science as a whole. Ultimately, the search for cosmic companionship is a reflection of our own human nature. Whether we find others or not, the act of searching enriches us and expands our horizons. So we return to that fundamental, echoing question, where is everybody? As of today, May 23, 2025, the universe remains stubbornly silent. The Fermi Paradox stands as a stark reminder of the limits of our knowledge. We have explored various compelling theories, from the daunting Great Filter to the rare Earth hypothesis, and even the possibility of alien technologies far beyond our current comprehension. Each theory offers a piece of the puzzle, yet none provides a definitive answer. The implications of being truly alone in this immense universe are staggering to contemplate. If life, particularly intelligent life, is unique to Earth, then humanity bears an extraordinary responsibility. We would be the sole custodians of consciousness in this vast cosmic expanse. This would make our survival, our art, our science, and our compassion all the more precious. On the other hand, imagine the day we finally detect a confirmed signal from beyond Earth. That moment would undoubtedly be one of the most transformative events in human history. For now, the universe holds its secrets close. The quest to find extraterrestrial life is not just about finding them, it's about understanding us and our place in the grand, unfolding story of the universe. The silence may be profound, but our determination to listen, to explore, and to learn is equally tenacious.